number 6, 7, 8, 9, 10, 11, 12, 13, 14. And you'll have several IRs. And then there'll be a legend that goes with each of those IRs, and it'll say OH stretch, C double bond CH stretch, normal alkane stretch, CO2 impurity, Fermi resonance overtones, carbonyl stretch, methylene stretch, methyl stretch, C single bond O stretch, or OOP bend, out of plane bend. So it'll have the 10 basic absorbances that I've given you, or 11, I guess it was, 10 plus 1 impurity. And you have to match those up. You guys follow that? Everybody follow?
So that worksheet that, or the table you like sent to us that we did last class, it's just like being able to say, okay, on this peak it's 1700 and this is like C double.
There you go. Now, on the worksheets that I sent you, this is the most important one. This is the most important part right here. It's asking you to sketch just what we were doing today. Now, I focused on this today because if you learn that, you won't have that much trouble with NMR, believe it or not. And I've had students pick this stuff up in just a couple of classes and be better than some of the faculty at it. You have to keep in mind what you're doing. But this, I don't know if you can see that or not.
Wait, I can't tell which. I have it in front of me, but I can't see what you're showing.
It looks like that. It's got a bunch of functionalities over here. And it tells you, it wants you to sketch. It says show multiplicity chemical shift and number of H's. So these are NMRs. It wants you to sketch what will this sketch? What will this functional group look like? It wants you to sketch a picture of that. It wants you to show chemical shift, and it's labeled for you. It's labeled the protons, A, B, and so on. It wants you to sketch what it looks like. Now, so I want you to do that for Wednesday. I want you to sketch this. Now, where do you get chemical shift? Right here. In these slides, you can even use this one if you want. Right here. There's as good as what you'll need to do that. Type of proton, and then it tells you the approximate chemical shift. So alkane, CH3, methyl group. Remember I told you it was about 0.99, about 0.98? There you go. I wasn't lying. Methylene was about 1.3, 1 1/3. You know, guys, it's not an exact science. It gives you kind of a roundabout where you'll find it. Obviously, if you have something further down the line in the molecule, an electron withdrawing atom, it'll pull this signal downfield. Or an electron donating will push this methylene group further upfield, and so forth. So the chemical shift you can get pretty easily, and that's the one thing you will have a chart for on the exam. And I'll show you what it looks like. I didn't want to show it to you tonight because I didn't want to hit you with too much stuff. But it's one that's easily read. It's the one I used all the way through grad school. And I swear it's the best I've ever seen. It's got the functional groups on the left, and then it's got an NMR chart. And it shows you kind of the area in parts per million where that signal will show up. It's pretty easy to read. Okay, alkane, 0.9, CH2 methylene protons, 1.3, methine protons, about 1. This is more like 1.5 to 1.6 for these methines. Now, methyl, guys, check this out. See what I'm pointing to? A CH3, 3 equivalent protons next door to a carbonyl. In other words, a methyl ketone. This will be a giant singlet, and I want you to write that down. Giant singlet at 2.1. If you have a gigantor singlet that integrates to 3 at 2 parts per million, you know you have a methyl ketone right there. That's a dead giveaway. Why is it a singlet? Why would these protons be a singlet? Tell me.
If you look to the right, it's your
You've
tag.
got nothing over to the right.
Sorry, look to the left. You have nothing, so nothing
Yeah.
plus 1 is 1.
Is 1. Exactly
Only
right.
one that it's attached to, correct?
Correct. It's
That's
N plus 1. You've got a carbon with no protons, so 0 plus 1 is 1. And that's what this is, a singlet at 2.1. So when you have a quaternary carbon, that is a carbon with no hydrogens on it, that means that whatever's attached to it has no protons on this side anyway to split these. Alkyne, again, these are super rare. 2.5, you just don't see too many of these. The only place I can, ladies, the only place I can tell you that